Alright, welcome back. Yeah, it took a while to actually debug this and fix this select tile source menu here so that you can actually go in and select the tile that you want. So I'm just gonna go through and show a bit how it works. Yeah, we have a bunch of constants here that calculates different things. So let's go. Okay, so first off, we have this grid width, which is basically you take the entire size of, or the width of the texture, and since these textures are always going to be square, that means they're going to be same height and same width, since the script that I'm using to pad the tile set is also making sure that it's actually a square. So you just take the width and we go through, we take the entire texture width and we divide it by the total tile width, which you can see here. And we're using div floor because when we divide, it's not certain that the width will actually be exactly multiple of this total tile width, so it might be a small fraction left over. But yeah, so that's why we do div floor here. So then we have the grid width, so that's how many tiles that fit in the width and the height as well. So then we just loop through these two dimensions, x and y, and we start with y because we're going through each row, or yeah, each row first, or not first, but each row when we loop through these ones, because yeah, otherwise there would be you would get columns instead of rows. So but anyway, so then we calculate the grid position. I think this is from before as well. We have the source rectangle there, and then oh yeah, I actually, this is like a later version I'm showing a bit in post here. So I also made this these selectable, so you can select them, but I'll skip that for now. And yeah, let's see. So the problem we had was that I wanted to draw these images, these tiles, and when you draw something in ImGui, okay, so when you're working with ImGui, it has this cursor that is like a position where to draw next. So the next thing that you want to draw, be it a window or text box or an image or whatever you want to draw, is going to be drawn at the cursor position. And you can change this cursor position if you want to draw things overlapped, things overlapping each other. So what I'm doing here is I'm looking at the cursor, or I'm calculating where I want the cursor to be based on the grid position here. So based on what the x and y is, when we loop through here, I calculate the cursor position. Then we can set the cursor position ourselves, so that we can both draw the image that we're doing here. So we're drawing the tile, and then we are also using this set point that we have to check if we are within, if the mouse is within that cursor, and then we check if the mouse button is pressed, the left mouse button. So in that case, we want to set the tile source. Never mind this if here, because that's when you select things. Or yeah, you know, if I added functionality, some other functionality, but just focus on this one. So when you just left click normally, we set the tile source to the target, which is the grid position, is the important thing here. Okay, so it's basically while we're drawing this, we check if the mouse position is in this position, and if we press the button. I think it's probably better to actually leave this if outside, because it's going to check this for every tile that's being drawn, so it's not really that optimal. But hey, it works, and I don't have to calculate the grid position because I already have it. So, but you could move this outside and just have one if, instead of it being for each tile, it's one if that checks for the mouse press, and then you have to calculate based on the mouse position relative to the window position, and then you calculate based on that the grid position that you actually clicked. I'm just doing it here for convenience, and it doesn't seem to take that much time. So yeah, and then we also put, we have same line here, so we put all in one row at the same line, and when we're done with the row, you can use this new line to actually force ImGUI to put the cursor on the next line, and then it goes to the next Y position, and it draws another row here. So that's basically how this works. And now we can go back to the recording here. All right, there we go. So now we can actually click to select the tile that we want. And yeah. Cool. Yeah, it would be cool if you could like paint a little thing here. Is that actually how it looks? I guess it is, maybe. Yeah, if you would do this, and then you could like have a select tool to select this and like copy paste, that would be cool. But and also like a bucket fill tool as well. But yeah, so now we got our basic functionality in place. And we can even put some moss in here. Feels like I'm missing something in here. This is not all the tiles. Oh, yeah, I've in my testing I actually divided this by 10. Okay, there we go. Now we see everything. Okay, cool. Oops. Okay, so I need also to check whether or not. Okay, yeah, I guess that's an issue. So also, why is it not selecting now? Oh, it's selecting the wrong thing now. It doesn't take scroll into account. Right, because we're checking only mouse position. Okay. Can we get scroll? Get scroll. Yeah, because this is an array and not a vector. Okay, let's do. That. Okay, so we get the scroll position like this. Then we need to calculate like mouse window position, I guess. Can we just cast this to a vector? And this would be, let's also do cursor position is a vector to F32. And then I'm just going to check this because in SIG, I know that you can do comparisons on vectors. I know that this is a vector, so what would be the result of this less than this? A bool? Okay, but is it or is it and? Maybe there's like different operators. All right, you use the reduce. My guess is it would actually be and. It checks everything, and if everything is true, then it becomes true. Let's just check here. So we'll do mouse position. As the mouse window position is more than or equal to mouse or cursor position, and mouse window position is less than or equal to cursor position plus scale size. So cursor position, cursor end is going to be cursor position plus scale size. And this guy is going to be a vector to F32. Scale width. Okay. So this would be cursor end. Oh, scale size. Right, so we still need this. Okay, so I guess this would result in a vector then. Okay, so then we do reduce. And no, it's not. It's a reduce of what? Why do I get mouse here? So it's and. Yeah. Wait. Reduce. Yeah. So it's like is mouse within cursor. This and yeah, I'm not sure which is more readable, but yeah, at least this constant is more readable, I guess. Okay. Okay, it works like that. If we scroll a bit, if we can scroll. Oh, we still need to fix that issue. If we scroll a bit down. Okay, yeah, it seems to work now. Yeah. Okay, so that's great. There we go. Okay, yeah, so that works. Cool. Now, yeah, we really need to fix the scrolling issue. I think maybe we can introduce, like, implement if you're scrolling with the, if you're holding down the middle button, you also scroll this view. So let's just add this here. If this mouse button down, middle, you get delta. Let's get it from this. Wait. Mouse. Drag delta. No, let's do vector to vector. It's going to be that's from Raylib. So we got the delta. Then we want to set the set scroll position. Wait, I don't wanna set the scroll. I wanna, like, I guess modify it from position X. Set scroll from position X. So I guess this is absolute here. I'm not sure what this means. Okay, let's just do this. Let's just get the current scroll. Well, we do have the current scroll, so let's do set scroll X. And this would be scroll position 0 plus delta X. These should be compatible. And then we have Y delta Y. Okay, so it needs to be negative. Okay, now we can scroll around this without having to deal with these scroll bars. Actually, I should just remove the scroll bars. So let's do no scroll bar. True. No scroll bar, but you can still scroll, like move with the mouse. Okay, cool. Yeah, that's way easier to actually use as well. All right. It almost looks like a top-down when you do this. Okay, cool. So yeah, I'm happy with this selection thing now. So one thing that I want to do is as well is to be able to save this. So that's the last part. All right, I'm back from post editing here, and yeah, the save file part took way longer than it should have. So I think I'm just gonna skip showing all of that chaos, and I'm just gonna show you the working solution that I have. And well, why did it took so long? So part of the issue was the kind of the way that the tile map is sort of allocated, and yeah, I think even I'm not sure about open file if we actually, well, I can go through that as well. So I'll just go through a couple of the things that I did to make this work. So first of all, we have this Tilemap arena allocator here. So this arena is an arena allocator, and this is part of the standard library. And what this does is it basically remembers everything that you've allocated with this arena, and you can call deinitialize on it, and when you do, it will release everything that has been ever allocated with this arena. So if you have a object with a bunch of smaller things in it and you want to see it as a sort of a large object that you want to basically initialize and then destroy all at the same time, then you can use an arena allocator to very easily just allocate everything within it with this arena allocator, and then when you're done with the whole object, you can just call deinitialize on the arena and it will deinitialize everything for you. So that's a really nice way of handling it, and I think the part of the problem is that I tried to use it without an arena allocator like the Tilemap, because the Tilemap had a bunch of, well, it has a bunch of small strings in it, like every tile has these source and tile set string and stuff like that. So if you have this set to some pointer somewhere, then you have to also deinitialize it manually if you're not using an arena. So, and also another thing is when you try to deserialize this from JSON, and so either you can use this one that I'm using here, which is parse. So there's a bunch of variations of this. You have parse, from, and then in this case token source, but you can also have from slice, or you can have from value, and every one of those variations also have a version called leaky, and there's one called not leaky as well, like this. And when you're using leaky, then it basically returns this type that you want to convert to directly, and it uses this allocator to allocate everything that it needs. So yeah, as I said before, the strings get allocated with this allocator as well. So if you actually put an arena allocator in here, then it will all get allocated with that arena allocator. And if we look to see where we actually do this, so this is the open file function, well, open file X, and I'm using that from open file. So this is where you actually have a file name. So in here we read, well, we initialize the reader stuff here from the file, and we also don't forget to deinitialize the JSON reader, because you will get memory leaks otherwise. And then we destroy we free the previous file data if there was any previous file data, and then we also set the file data, so the new file data is going to be this deserialize, and now we're using this Tilemap arena allocator here, and you have to call allocator to get the actual allocator out of the arena, because this type is arena allocator and it's a different type. But if you call .allocator, you will get an allocator that works with the arena. So everything that is allocated with this allocator will be put into the arena, and once you're done with the object, as we're doing in free file data here, well, yeah, you can deinitialize the arena. Here we're using reset and free all option. So this will basically just free everything in the arena, and then you can reuse the arena for allocating other stuff. So it just frees everything in the arena, so the previous tile set is freed, and then you're free to use the arena again when reading the new Tilemap here. Yeah, another addition I did was to add this current file name. So basically, as with most editors we have today, the editor remembers the file name or the document that you have opened. So when you save, you don't get a file dialog to tell you, oh, where do you want to save it every time. If you already have a document open and you click save, it actually saves it to the same document that you have open, basically. So this is basically like the currently open document file name. And from the start, this is null because we have no file open. But once we have opened the file, we can see here that we are setting the current file name to a copy of file name here. So we will actually remember the file name, and then when we go to the save function, you can see here that it checks first, like, do we have a current file name? If we have, then we get the file name and we call the inner save function, which actually saves to that file name. Otherwise, we will call the file dialog. And yeah, in NFD, native file dialogs library here, we have a function called save file dialog. So here you can put a file filter, which we've shown before, and I've changed it to actually be tilemap.json. So we have specific, actually 2 extensions for this file, because I'm gonna have like different types of JSON files. So I want to have one for tilemap and one for like animations, something else. So it's nice to have that filter, so you only see those kinds of files. And then we put our default path in, which we actually have here now. So we have a default path that we allocate from the start here. So we allocate the default path like this, and yeah, so this is actually, yeah, it returns this pointer or slice here, which is 0 sentinel. And I had a bit of trouble actually getting this exactly this type of well, actually here the LSP doesn't even say it's a 0 sentinel, it says it's just a normal slice, but actually it is 0 sentinel because the return type of alloc print z actually is a 0 sentinel string here. So, and that's what we needed to pass into the native file dialog system, so that's why we need that. There was actually no way of actually doing, like, you have real path z, but it doesn't actually return a 0 sentinel. It accepts a 0 sentinel path name, but it doesn't return a 0 sentinel. So there was no kind of thing for real path that did that built in. So I had to use this print version to actually do that. And I realized that I might not need to actually use alloc print z here. There might be a more efficient way of doing it, but this is the way that I chose to do it right now. So, but we have this default path here, and that gets freed when we initialize the thing, and it only happens once. But yeah, back to the save file. So yeah, that's the save file dialog call. And then when you actually use, if you're gonna use this library, you have to use free path instead of using any allocator from SIG. This actually uses the C allocator from libc to, well, malloc, I believe it's using the malloc function to actually allocate this, so it has to be freed with this special function. So yeah, that's how you do that. Yeah, and down here we do a check to see if the extension of the file name is tilemap.json. So when you're actually saving the file, and if you forget to type, or if you don't want to type .tilemap.json, we will do that for you here, or for the user here. So here you see that if the extension is not tilemap.json, so we're using standard mem equal to check for equal strings, and we're using standard file system.path.extension to get the extension of the name, and this will return the extension here. So actually, yeah, you can see here that it includes the dot, so actually we could have the dot included here as well. Yeah, so this might actually be a bug because if it's not equal to .tilemap.json, then I believe it's not going to go in here and just do this. So yeah, that might actually have been a bug. So actually, I think you have to have this .tilemap.json. What you also could do is you could just say there's another function called mem. So mem is basically, you can use this as a sort of string library to check for different things. So you can do ends with, provide the type, which is U8. Haystack is going to be the file name. And then you have needle, which is .tilemap.json. So this would also work. I guess this is probably easier to look at as well, instead of doing the extension thing. I mean, this is, I guess, more canonical, or whatever you want to call it, like more safe maybe. But it's, I mean, it's not, it's gonna be this anyway. So I think I like this better actually. So ends with, because even if we forget the dot here, it's not a huge deal. So anyway, never mind. So yeah. Anyway, so yeah, if you don't have .tilemap.json, we will actually add that for you, so you don't have to type it all out. Okay. And then yeah, if you actually have if you actually have .tilemap.json, we just copy, I guess, yeah, we just copy this file name over to current file name here. Yeah, and then we call this inner save function, which yeah, so this one assumes that we already have a file name. So we get the file name, and I have this debug log here to check that we are saving. And then we use this create file absolute function, which is in the standard library file system module, and we will put the file name in here, and then you have some flags which we don't need. So this, the basic version is basically gonna create a file. It will, if there's already an existing file, it will write over it, and you will start from scratch. So it will overwrite the file. Then we defer close the file, and we also create a writer, because then we pass that into our serialize function, which is then just, yeah, just this. So this is pretty straightforward. We call print on the writer, and we put an interpolation in here, and with the value is going to be string, or sorry, standard.json.format, or FMT. And well, yeah, it's FMT, but it stands for format. And then we put the value that we want to format, which is our file data here. And then yeah, these are like stringify options, which we don't have any. And that's all you actually need to do to actually grab a writer to format some JSON into. Actually, I think you can use stringify instead. So you can use stringify, and this is going to be self. We don't have any options, and the writer is going to be this. So I think this is equivalent actually. Yeah. All right, so yeah, I verified this, and this works. Yeah, just as fine. So you can do either way. You can do writer.print and just use it as a normal print function, and use standard JSON.format, and then the value and stringify options. So this works either way. But if you have a writer, then it's more convenient to use stringify. So you just put the value, stringify options, and the writer here. So that works. One modification that I needed to do to get this to work was that I did not need to pass in the pointer to the writer here. I just needed to put, yeah, you can just get it as a constant and put it there. So that seemed to work as well. Yeah, so it seems that this writer is safe to copy like this. I believe it's just it has a context, I guess. Yeah, it depends on what kind of writer maybe you are going to use, but this one, which is a file writer, is actually, yeah, it's just a handle. So this handle is, I think, just a, yeah, it's just a I32 in the end. So that's all it is actually. This writer is an I32 with a bunch of functionality to it. So okay, so that's fine to copy. But yeah, so that's basically it. So then this stringify will actually use this writer to write to the file, and in the end we're gonna close it. And it's writing the file also like in a streaming manner as well. So okay, and we can take a look at open file as well. So open file here. So much like the save file, we grab some kind of file name first, and once we have a file name, we call the inner function here with the file name. And yeah, so for open file, we don't, yeah, we just open the file dialog, and same thing here. We put in, we use native file dialogs. We have open file dialog here, and we use the file filter, which is tilemap.json, and then we also put the default path in there, which is the current working directory. Okay, and then we get a file name maybe. So maybe the user cancelled the dialog. In that case, we don't have a file name, we have a null. But if we do have a file name, we get the file name here, and we free that file name with free path at the end, and we also open the file with this inner function. And so this is an absolute file name, so we open it here, we defer close. And much like the writer or saving the file, opening, we do basically the same thing, except we're using a reader instead here. And with JSON, you also have to do this JSON reader. If you're going to use this reader, this file reader, you have to wrap it in a JSON reader. And then you also have to deinitialize the JSON reader, which is very important. And then, wait, I already went through this. Yeah, but anyway, we free the file data and we deserialize the file data, which is just parse from token source leaky here. But we do pass it, this is the important part, so we do pass in the arena allocator here, so that we can free everything, because I tried to using a normal allocator, and yeah, it was really hard to get everything deallocated. So much easier with an arena, everything gets deallocated, it's fine. And then we also set the current file name here. Okay. Okay, so I'll just show you the buttons. So that's very, very simple. We just have a file menu function here that we call from the main menu function. So this is below the file separated text there. And yeah, we have open, I believe, from before, open file, and then I put same line here, so they are going to be rendered at the same on the same line, and then we have save. Okay, so I'll just show you how it looks now, and now I've enabled so that you can see the dialogues as well. So I click open, and you get this nice native file dialog here. And I can go to my game. Okay, so this is my game folder here. And then I can open up, so here we have two maps, so let's open up test. And there you can see, so we loaded in that one. And then we make a bunch of changes, so we delete a bunch of stuff here. We click on save. Now, because we remember that we have this open, it's just gonna save the file. It won't actually you won't actually see a dialog to open it up, but if we close down and we open it up again, then you can see that, yeah, it actually, well, this version, which I'm not going to show the implementation in this episode, but the next one, I think. Well, here you can see that we've opened the file again, and it successfully saved as well. Okay, so let's see how the save file looks. So I'll just pick some tile here. And then I will save this, and now you can see we get this save dialog. And if we go down here, we can type anything, like we can type like I don't know, test2. And if we try to open now and we go back, wait, okay, so that actually didn't work, so I actually have to... Okay, so that actually didn't work, so I have to go to context and let's go to tilemap.json. Okay, I see. I did a very logical error here, let's say. So this needs to be not here. If it doesn't end with .tilemap.json, we add .tilemap.json. Alright, so we'll try saving a new file. So let's paint something here and then we do save. And here you get the save dialog. And we'll go to our folder here and we'll try type, if we just type test2 here, it should save it as test2.tilemap.json. And if we open up our folder here, we can see that we have test2.tilemap.json here. It might be a little hard for you to see this actually, I just realized, but yeah, it's showing up. Maybe I can change like extra large, I don't know, no. Okay, yeah, anyway, it's there, test2.tilemap.json. So yeah, and then once we have it opened, we save it. It remembers that it saves it as test2.tilemap.json. So if we open up another one here, and then we can go back to this one again. Okay, I'm going to add a couple of shortcuts that will enable me to press some keys on the keyboard to open files and save files. And I might do more if I think of anything else I can do. So let's add these to the to-do list here. And I want, yeah, Control S to save, Control maybe O to open, and maybe even Control plus N to clear the tilemap, or yeah, make a new tilemap. So let's go into our source code here and we'll do that. So we'll go into layout and we have a function here called handle input. So this layout is our main like function where we draw everything and handle input and stuff. So at the end here we handle the input, but this input is mainly used, yeah, it's used when the UI library does not want to capture the mouse input. So I guess I could put it in here. So here we have a bunch of stuff going on here. So this is basically what's happening when you interact with the tilemap view. Because if you're not doing that, then you're interacting with some window in the GUI library. So, but what I want to do is I want to have shortcuts. So let's have that here, handle shortcuts. and we'll need the context. Oops. There. Okay, so now we can put it in here. So what we'll do is, I guess, yeah, we'll just have a very naive first approach here. Later we'll probably want to have fully customizable key bindings and all that, but right now I'm just gonna add these real quick here. So we'll check key down with raylib here. So if key is down, and I'm gonna say left control. Come on, left control, yeah. And is key down, well, I guess is key pressed. So you hold down the left control key and you press S, key S, yeah. And if you do that, then we should just save. So yeah, I'm just gonna do this and look in here, because I believe, yeah, if we have a current file name, yeah, so that's gonna be the same trigger as when you click on the save button. Yeah, so here's our save button. When you click on it, we call save file. So that should be the same thing. We just shortcut it into there. Okay, and I'm also going to have, let's just put this actually in a separate thing. So this could be control, and then is key down dot key S. Then we do this, and we can also, I guess we can return at that point, because we're not doing any other shortcut than that. And then let's check also for key O for open. So let's do that, open file. And then we also have, so I mean, yeah, that should actually be enough. So when I open this, okay, we have an issue here. So a handle shortcut needs to be try. So I press Ctrl O, I open my file, I will edit it and save. Okay, and then we reopen, and I will open up a file again, and there you go, it's saved. Okay, cool. So great. Maybe I should probably add like a little loading thing when we save, but it happens so quickly now that it doesn't really matter. Okay, so that was quite easy to add. Oops, I should resize. Okay, so let's go back to our to-do, and yeah, we've done these two already. So I want to add the ability to press Ctrl M to make a new tile map. And we'll go back to our shortcuts. And so we can add a shortcut for N, and that will simply call new file, and we don't need to try this one. Okay. So let's open the village tile map, and we will do some things here. Let's not do anything, but we'll try Ctrl N now, and there we go. I just want to add a label as well to see that the current document opened. That should be pretty straightforward. So we'll go to our layout. Now in our main function here, we have main menu, and in this one we want to say, yeah, here's our menu window, and I think we'll remove this demo now. We don't really need this, and we'll just say if we have current file name, then we can do I guess a label text. Wait. the label format arguments. Oh, so this is like file, and then the format is this, and then the arguments is this. I'm gonna guess that this is how it works. Let's test it out. And let's open the village. And okay, yeah. So you can see it kind of cuts it off here. We should probably... Okay, so I think... Can I do only text maybe? Text... Yeah, let's try that. Let's just do text, and it's going to be this. But what we want to do... Okay, so let me just see how that looks first. Okay, so it looks like this. So what I want to do is I basically only want the... I wonder if you can add like a hover, like a tooltip. Begin tooltip. Okay. So what does that do? Oh, maybe you can do if, and then, I don't know, text this. Okay, so, oh. I wonder how you actually make it. So this is just making a tooltip. Okay, I see. So how do we actually like hover? So hover is item hovered. Okay. So which item are we talking about? I guess the next one maybe? No? Which item are we talking about? Padding, stationary, delay now, root window, 4 tooltip. Okay, let me Google this real quick here. Okay, so you have it after. Okay, there we go. And I want to add a little bit of delay to that. I guess short. Yeah, that's perfect. So yeah, so what I want is I want a short version of this. So I'm only gonna have like the base name. So what we'll do is we'll say base name is going to be, I think it's IO, wait, is it FS path base name of this. Is there a way to do it with Sentinel? I guess not. I guess that's, yeah, I guess we need maybe another, wait, but this one should work, right? This is the base name. Yeah. So let's go and open up that, and we can see this is village. Okay, I want it without the extension, but here you can see sort of what I want to have. I want the file name, but I want I want to remove .tilemap.json. But then also, if you want the full name, you can hover it and you can see the full name there. Okay, cool. So let's also remove the extension. So is there a function for that name? I guess what you could do is you could say, once we have the base name, you can just use memory here, and you can say, I guess, let's see if there any good function for this, like trim. No. Split. So maybe split, and then you just take the first thing. Yeah. Well, split scalar. And then this is U8, the buffer is base name, the limiter is dot. So this is the iterator, and then you grab the name, which is going to be iterator.next. And we will just assume that there is one, because we're always opening .tilemap.json files. And that should be the name that we want. And we don't allocate anything here, so we can just leave it as it is. And there we go. Now we got the village. And we'll open up test, and we have test here. So now we can also see what map we are actually editing here as well. And then when we do a new map, it disappears. Okay, sweet. So let's do this. We also added label to show current file opened. Currently opened file. Okay, is there anything else I wanna squeeze in here before we end? Oh yeah, so one thing that I'm thinking about also, is for convenience, is to open the last file that you have opened before. So when you close the program, it will kind of store the state that it was in, and when you open it again, it will open it to the same state. So that would be really cool to have. That's a bit larger thing, I think, but let's see if we can get it done here. So I think we'll do store editor state when quit on quit, and load editor state on startup. Okay, so first I want to define the editor state. So let's get to our, I mean, we have our context, and what we would want to do is, I think we want to have a separate state, which is going to be here. I think, actually, what we're gonna do is I'm gonna just define a new thing here. So this would be, what would this be called? Like editor session maybe? So this is an editor session. Okay. Now what we want is we want to have the current file name, and we also want the camera. So I want to restore everything basically back to what it was, even the size of the window as well. So I think that we'll grab that as well, window size, and this will be just a vector. And I do want to store the current tool as well. And so this one, I'm not gonna default these. Okay, I might have to change around some types here, but we'll see. Alright, and then that should be good. Okay. We don't need to store anything else, I don't think. So I think what we could do is pass in a context, and it will create an editor session, or maybe the context will have that functionality. So the context could have a function called create editor session, and this will pass out an editor session here, and we will have our context here. Okay. And then we will load it in, or import it here. All right. Wait, I just thought of something. When you have an init function, can you actually do this? Is that a thing that you can do? No, you can't. Okay. Because sometimes when I autocomplete these things, I get some weird thing. But anyway, okay, that was not possible, but it would be cool if that was kind of like a syntactic sugar for that. Okay, but anyway, it's fine if it's not also. Unused function parameter. Yeah, let's see, let me get my mind back to where we were. So yeah, we need to create an editor session. So first we'll create the editor session pointer here. So we'll do allocator.create an editor session, and this is going to be cache unreachable there, and then we return this one. Okay, now we want to populate it. So editor session dot current file name is going to be equal to editor session. Actually, you know what, maybe we don't actually need to create a pointer here. let's just return this like this, and we'll set this to be self.current file name. So this would be like a borrowed sort of thing, so we don't really want to deinitialize it when we use the editor session. We just use it once to actually save the data. Save. So maybe this is a private function actually. Yeah. And the camera, we can set it to this. So what is this? This is just 2 vectors, and those are structs with x and y, and then 2 f32. So that should be fully serializable and copyable as well here. And then the window size is just a vector, and the window size we can get from raylib, and we can window size, I think it's screen width and screen height. Yeah, so we'll make a new thing here, screen width, screen height, and that will store the window size. And then we also have the current tool, and we'll set that to be self.current tool. Now I'm just gonna check the type of that, because this might not actually be serializable. We've got this name, that should be fine. We've got this brush tool with the tile source, this should all be fine. This is a bool, this is a select box, vector, and an array, so that should be fine. And the tiles, yeah. So that should all be serializable. So we'll just save this as a JSON file, I think. Session.json or something like that. Okay, so now we actually have a editor session that we can use. So let's have a function called store session. So we will actually want to have a file that we do create file, or actually this would be current working directory, and then create file, and then the file name is going to be session file name. So this one should be session.json, we'll say. Session file name. And then we have flags. I don't think we need to do anything with those. Okay. So now we should have try there as well. So now we should have our file. Now what we want to do is we want to create a, well, yeah, we want somehow to put in JSON there. So what I'm gonna do is I'm gonna grab the writer, and I think this is how you could do it. So then you do standard JSON, and you want to stringify, and the value that we want to stringify is going to be the create editor session, and then the options, we don't have any options, and then the outstream is just going to be writer, and I think we need to store it, to put it as a thing like that. I'm not exactly sure. Let's try without first. Okay, so that should actually just push it out into the file itself. Now we also need to close the file, so let's defer that. There. So that should actually store the session itself. So let's try that. Let's go to so now I think let's check out where we can do this. Here's our main function. So after we are done with run, I think we can do that. So let's do try context.save, no, store session. Okay. And we got some errors here. Error union is ignored. Okay, so this one, wait, this one, no, this one has an error, yeah. Okay, recompile. So let's just do this. And let's check our files. And we have a session.json here. So let's check that out. Okay, that looks cool. Okay, so we've got our camera, we've got our window size, the current tool. Yeah, that's all looks pretty good. Okay, so let's try and make a restore function. I think we can actually check this off now. We are storing our save on quit, or our session on quit. So let's actually make a function that's called like restore session. And I think what we want to do, do we want to have an initialize? I think what we want to do is we want to have an existing context that we change. But yeah, let's now open the file here instead. Okay. And then we have a reader instead of a writer. And we also have a JSON reader. This is style JSON reader. Allocator is self-allocator. The reader is reader. Okay. Somewhere in this we need to put a ampersand somewhere here, but let's just do it like this for now. So then we do we do try, and then we need, what do we need? JSON dot parse from, why am I not getting any? What's happening? Parse from token source leaking, and this type is going to be the editor session. Let's make it, no, I think we'll try this, and then allocator, and then the scanner or reader is going to be the JSON reader, and then no options there. So this should get us an editor session. Okay. Then we need to use the values that we get from this, and we also need to destroy it. So actually we probably don't really need to do leaky here. Let's do just token source. Yeah. And then we get a parsed value. And then we can defer parsed dot initialize. And this file is going to be freed anyway. Yeah, I'm just checking if it's safe to do this. I think so. So then what we need to do. So first off, we need to open the file. So we need to do open file. Let's do try open file. And oh wait. This actually, we need another open file. So open file. I guess X, where we actually have a file name already. Okay, so then we can do this. And then here we can remove all this and we can say file X, file name. Okay, great. All right. So that's, now we can do open file. So we can do open file X, and the file name is going to be whatever is in parsed here. So it's going to be parse.value.current file name. I guess if we don't have a file name, we don't want to open it. So let's just check that first. If we have a file name, then we should open that file. And we should use that. Capture that. Okay, so that takes care of opening the file. So we should actually have a working thing here. It won't restore the other state yet, but it should restore everything, like the file name that we've opened. So let's go to our main file, and we'll do, after all this, we'll do try context restore session. Also, I think I want to check here, if we cannot open the file, what happens then? So I think we want to catch an error, and we want to switch on that error, and we want to see, so this should be file error, open error, not found, and this would be, if it's not found, then we don't really need to do anything. Otherwise we will just return this error. Okay, so let's try that. Let's actually try just running this. Okay, we've got some issues here. Okay, here we go. So this says that the reader needs to be a pointer. So I think, which one is it? It's from scanner. It's probably maybe this. This needs to be a var then. Okay. Wait. Maybe it's this one? Okay, so it was the JSON reader that needed to be a pointer. Okay, so let's open it up, and yeah, it didn't crash. Let's try and open up a file here. We'll open up village, and I will quit and open again, and there you go. Now we have the village being opened again. Cool. And yeah, so that works actually. That was way easier than I anticipated. And okay, so then now what we want to do is we want to say that the tool that we're using, the current tool, we want to set this to this tool. However, we probably want to basically, the thing, yeah, the name here is actually, what we want is we want to grab that name from the list of tools that we have. So we want to match that tool. I think actually let's just not do this for now, because I think this is a bit more involved. Need to properly clone the tool. Okay. Now, but one thing that I really want to actually restore is let's actually restore the window size. So I think what we can do, we can actually set the window size here. Yeah, so we'll just set it, and the width is going to be parsed value window size 0, and then this one is window size 2 or 1. Okay. So we'll do that. Let's expand the size, quit, reload. Okay, so it expanded, it saved the size but not the position. So that's okay. Let's store the position as well. I'm actually not sure if that's possible, but we'll see, probably. Let's see, store session. Create editor session, so we need to have the window position as well. Can we get that window? I guess we can get window position, so let's do this, and then we do break and win position X, win position Y, and these actually need to be vector 2 F32, and then we do a int from float. And then you are a vector, yeah. So that should work, hopefully, maybe. Okay, no errors from compilation. So that gets us our window position as well. And then when we have that, we can say set window position. And this is parse value window position. Probably safe to do that last as well, so that's good. And oops, value window position 1. Alright, now let's also test removing the session file, and it should not crash now. Okay, great. So let's do this, and then we'll open it up again, and it restores the window position as well. So that's awesome, because then I don't need to fix that every time. Okay, cool. Should probably also store like the coordinates where you're looking and stuff like that, but this is good for a first pass. The only thing we don't have, oh yeah, actually we do have the camera. We can just copy that, I think. Self.camera is just a camera, and we just set this to parsed value camera. Okay, we zoom out a bit, move this around, save, load, and there you go. There's the camera as well. So yeah, that's how you can actually set the window size and restore it. The only thing with that we're not restoring now is current tool, and there's probably more state that we wanna restore in the future. But this is a great first thing. Oh yeah, so remember that I talked about current file name, and we actually copy or duplicate this with the allocator. So I got a memory leak here and complaining about current file name. So we actually have to free this if it exists. We need to call the allocator to free this as well. This is this one, so that's the slice there. Okay, let's try that. And there we go, we don't get any memory leaks anymore from that. Great. Okay, so yeah, saving, opening, everything works. But I'm thinking, since I have this all over the place, I feel like I need to create a function for that. So let's do that. I think we can do it up here. So I think what we'll do is we'll have like set current file name, and we will get a file name here, and then yeah, this will be void, and then what we'll do, well, I think it needs to be this, because we're gonna allocate here. So I'm thinking I'm just gonna do this here. So if current file name, oh, we need self here, of course, self context, and we're just gonna check if current file name is equal to file name. We'll free that, and once we've done that, then we can say current file name is equal to self allocator dot duplicate, and I believe this is a 0 now. Yes. And so this is U8, and this is going to be the file name, because the input is not necessarily 0 terminated. Okay, great. And oh, this is a channel. Okay, yeah, so let's rename that to that. Okay, yeah, and we needed to change that because it was shadowing this, and SIG is very, very picky about shadowing. You can't shadow any at all, and shadowing basically means you have the same name. So we don't know which. When we do this, we don't know. Okay, do you mean this file name, or do you mean this file name? I'm actually used to being allowed to shadow in other program languages, and then usually what you will mean when you actually use the file name, because oftentimes the programmer decides to actually shadow, and it's like the programmer does it on purpose, and the purpose is to just have a convenient name for it, and the purpose is to use, or the intention is to use the actual most inner. The intention is to use the identifier that is in the closest scope. So for this example, it would be this one, but since SIG doesn't actually allow shadowing at all, we have to rename it to something else. So it's not a big deal, it's just a bit inconvenient sometimes. All right, so that's good. I mean, I understand why it's done. It's to avoid confusion and potential issues regarding that, so that we actually know exactly what we mean when we say it. But anyway, we're not here to argue about that. So okay, now we have this function, and it will basically always duplicate this file name. So we'd have to know that, okay, we can actually put a comment here. So file name will be duplicated, and will be duplicated. Yeah, that's yeah. So the caller will know that, yeah, you can't just pass in this and forget it. You have to free it up if you need to. Okay, and then we can, let's see. Here we are setting file name as well, so we should probably use that function then. Yeah, because this will also lead to a, well, actually it won't need it necessarily. Oh yeah, it actually won't lead to a memory leak, since we're checking if we actually have a file name up here, and if we have that, then we return. So this only happens if we don't have a file name, so we don't really need to use the method here for setting the current file name. Okay, so let's go down to open file, and yeah, when we're setting the file name down here though, we actually want to we want to call set current file name, and it's just going to be file name, and that will get rid of all that. So that's a bit nicer to look at as well. And I think we need to try it as well. Yes. Okay. And then we have new file, which also does basically the same thing, except we set it to null this time. So I guess actually this set could take a null here, nullable. So then we can say if file name, and we get the file name there, and we can say, oh yeah, we can't use fn because that's a keyword for function. So let's do, I don't know actually. Let's just call this a cfn for current file name as well, and then we duplicate that. Otherwise, we want to set this to null. Okay. Actually, we could probably yeah. So if we do this, then we just need to check for that after. Because this kinda is an operation that you want to have. You basically, if you free a pointer, you don't really want to have it around. So we free something, we set it to null. That's a common operation, and then we check. Okay, do we have a new file name that we want to set it to? And in that case, we copy that over as well. Okay. Right. So now down here, we can actually just say try self set current file name to null. There we go. Okay. Okay, but I think that this is going to be it for this episode. So thank you very much for watching. Have a nice day. And if you have any questions or any other comments regarding this project or game development or anything in SIG related, feel free to comment. Feel free to post down below, and I'll see you next time. Bye bye.